Today I'm going to explain the motion of a projectile. It's actually quite simple. I'm going to be explaining it using really simple calculus, nothing too complex. Basically, you want to set up your your functions for x and y. For the x, that's going to be the distance traveled, so we know if the particle starts with an initial velocity of v naught, it's going to travel the distance v naught cosine of alpha times time, and I'll draw a picture over here. Got alpha, and this will be x, and this will be y. And yeah, so the distance traveled is going to be v naught cosine of alpha times time, and the y the y location can be given by v naught sine of the same alpha times time minus 1/2 gt squared, and this is its change in location due to the acceleration of gravity. And I'll just fix that up real quick. And this is actually really easy to do now. Basically, you want to find the time that the y value will be the highest, so the maximum height, and that's really easy to find. You can just take the derivative of this whole thing, so y prime is equal to v naught sine of alpha, there's no t anymore, minus gt. And now if you set that equal to 0, because we know taking the derivative and setting it equal to 0 will give you with the maximum. So we can set it to gt is equal to v naught sine of alpha, and solving for time we get time is equal to v naught sine of alpha over g. So that'll be the time in order to get the maximum height. And now if you want to find how far horizontally it is traveled, again, you can just take this time value and plug it into x. So if you want, you can do x of t is equal to v naught squared cosine of alpha times sine of alpha, and it's all going to be over g. So that's going to be the horizontal distance traveled at this maximum height y, and so that's pretty easy. Yeah, if you want to find the horizontal distance traveled after the projectile has re-landed, that's pretty simple too. You just set this value equal to 0 for y, because it will go up and then it will come back down, and this can be given by let's see, we set it equal to 0, so 1/2 gt squared is equal to v naught sine of alpha times time. And we can cancel these out, and you end up getting that the time is equal to 2v naught sine of alpha, and it's divided by gravity. And so that's going to be the time for the projectile to re-land, and if you look, it's 2 times the equation for the maximum height, because if you think about it, you've got a parabola here, it's going to launch, and then it's going to go back down, and it should be split right among the middle, so this should be 1/2 of the distance between both of these, and that's what it seems to be. And so it works out. But now you can you can also plug that back into the x to find out the let's see. Yeah, you can plug it back into the x in order to find out how far it has traveled horizontally at this time. And just like before, it'll end up x of t is equal to, and it's going to be 2v naught squared times cosine of alpha times sine of alpha and over g. So that's how you derive the range of a projectile. And like I said, it's really not that hard. If you know some simple calculus, then you can do this really easily. So on that note, I hope I helped you out, and keep watching. Thanks.